Okay, in this short video, I'm going to discuss drawing a room in linear perspective and using a couple of student examples as a way to analyze some of the more common problems and how to fix them. Now, this ability to draw a room in linear perspective was a challenge to many artists throughout the history of Western art. If you go back to the Greeks and Romans, there was a rudimentary form of linear perspective, but it really didn't get sort of figured out and nailed down till about the 15th century, when this gentleman, Filippo Brunelleschi, the creator and architect of the Duomo, is credited with actually figuring out how to find vanishing points, orthogonals, horizon lines, all of that stuff that we've discussed in the previous video in terms of linear perspective. So between about 300 AD and 1400, most artists in the West were pretty blind to the structure of how to draw geometric solids in 3 dimensions based on the optical properties of the eye. So it's no surprise that when given the task, beginning students without any background or training or instruction would find themselves dealing with issues and problems in the perspective drawing. So I've asked a couple of students to borrow their work. Thank you very much. It's what's amazing about these drawings is how much they were able to get right. If you think about, it took nearly 1,500 years for Western artists to figure that out, and these students figured most of it out within a week without any kind of instruction. So kudos to them for getting so much right, but what's important about these drawings is there's a few things they got wrong, which are the kinds of mistakes almost everybody makes at some point with linear perspective. So I'm going to use their drawings as a way of talking about what's wrong, why it's wrong, and how you can fix it. Okay, so the first drawing here, if you look at this room, for the most part, the room itself is in linear perspective, and we know that because if we connect the diagonals for the ceiling and the floor on both sides in the box, they appear to be converging at a vanishing point, 1 point, which is what should be happening in the drawing. And that vanishing point is on the level of the eye, so the eye level. So we can see right here that the vanishing point is fairly high in the room. We know from the previous video that this is the eye level. So you can tell from this drawing that if it was correct, the person would be standing up. And we know that because the distance between the ceiling and the floor, and we can do that on the back wall or in the side wall, it doesn't matter, in most houses is roughly about 8 feet. So if that distance is 8 feet, we know that around here is about 4 feet, so there is probably 5 feet. So if this was an accurate drawing, the person would be standing up to make the drawing. If they were sitting down, this eye level would be much lower. Okay, so that's the first thing that's really important to keep in mind when you go into the drawings this week. Your eye level has to be straight ahead. So if you are sitting down, your eye level is going to have to drop. Okay, and it's also going to be straight ahead. So if you're sitting in the middle of the room, the same distance from both sides, you're fine. But if you're sitting to this side of the room, the vanishing point needs to be over here. Okay, so what we find problematic in this is the door. So if you look at the top of the door, it's going up. As the top of the door is parallel to the ceiling line and the floor, we know from the rule of linear perspective that all lines that are parallel to each other go to the same vanishing point. We know that this line has to go here somewhere. It can't be going off into its own spot. So it has to go to the vanishing point. So this would then cut the door off. Okay, so one option could be that we go from the nearest part of the door and we draw a line parallel to the ceiling to the vanishing point. And if you could imagine how that might look, it's going to give you a lot of space above the door. Alternatively, you don't have to go from the near side of the door. You can go from the far side of the door, and that would look like this. You would just, from this point, if you line it up with the vanishing point, you then just work backwards towards yourself, and you see that the top of the door is now parallel to the ceiling. It's actually getting a little wider as it comes out here, a little narrower, you can see as it comes closer. And so we would then have to redraw the top of the door so that it fits that line, and then we'd have to extend this vertical up. Okay, so here is what you would get, right? So the top of the door is now going down to the vanishing point. And that's because we wanted it to be close, so we took this point, but we could have equally have taken this point. It just would have given us a shorter door to work with. Okay, so now you can see the door is in perspective with the rest of the room. Now we look at the table, we find that the table has its own vanishing point. And if you remember previously, the vanishing point is actually over here. Okay, so this vanishing point is on the same eye level, which is great, right? So that's very, very accurate. The problem is because the table is set up in the room so that the sides are parallel to the room, and we know that because these are horizontal, right? The table is not angled. This is angled, and I'll come back to that in a minute. But because these are horizontal, we know that the sides are parallel to the sides of the room. And so again, following the same rules, it has to go back to this vanishing point. So this table in accurate linear perspective drawing would look like that. Okay, so what you would end up doing is you'd be erasing this little corner sticking out here. This is your new corner. And then here you would have to extend it out, which I haven't done. I'm just pointing this out to you. All right. Now this other object here, this is not in 1-point perspective. This is in something called 2-point perspective, which we've seen briefly, because this is at an angle. And because it's at an angle, we get one vanishing point on this side and one vanishing point on the other side. And the problem with it is, notice that these lines are totally parallel. Just like the table, they have to come together. They have to converge as they go back in space. And they have to converge on this point right here, so this eye line. So you can see that if this is going to be here, this line would have to go up there, and this line would have to go up there, which would be rather odd. So it's more likely that the middle line is going to be closest to where our vanishing point would be. And so to put this object into correct linear perspective, it would look like this. So I kept the middle line the same, and I just brought the bottom and the top to the same point. So even though the point is different, because it's 2-point perspective, it's still on the same eye level. So you can see what you would have to do is erase this corner, this is your new corner, and erase this corner and bring it up. Okay. The other side of the object is in correct perspective, because you can see that the vanishing point is on the eye level. So that's really, really good. So only half of this object is wrong, but then the same would also apply to the TV. The top of the TV cannot go up here. It would have to go to this point because it's parallel to these lines in real life. And if they're parallel in real life, they go to the same spot. Okay, so that's the first drawing. Overall, pretty good. Just some good observation of eye level and getting some things on the right eye level, but just working on tweaking the door, the table, and one side of the box. Then when we come to the other drawing, we can determine the perspective, the linear perspective vanishing points just by extending the corner lines. Now I can pick any line, but it makes sense to just start with the box. Start with the box of the room. Don't get too involved in details. So if I do that with the bottom line, I see that they meet here, but the top meets there. So you can see immediately there's two different vanishing points, and that can't be the case. They have to be the same. So again, if this was going to be our vanishing point, then these lines would have to come up, okay? We can see the top of the doors are coming to the vanishing point. We can see the top of the window, the bottom of the window. So we can see that this is really the dominant organizing vanishing point in this drawing, okay? Even if we look at the table, the side table down here, we see that the edges of the table are also in correct perspective. So this vanishing point right here is the key to the whole drawing. And we can see both sides of the table. This one's a little bit off. You know, it's got to go to this point here. It looks like it's going to miss it a little bit. This table is having a different vanishing point. So again, this line would have to go back. So really what you do is you establish this dot first, and then you work back this way, as opposed to drawing your table, measuring, lining it up. If it's wrong, erasing it, drawing it again, lining it up. You get your point established first, and we'll be talking about that in the videos this week. Now the bed is also lined up with that, which is good. So the real problem is this bottom vanishing point. So to correct this drawing, this vanishing point would have to be up here, okay? In which case these lines are going to be along here. All right, so they're going to come lower on this side, lower on that side, and that way all the vanishing points will go up to that spot. Now again, like the previous drawing, look how high that is. Again, if this is 8 feet roughly from ceiling to floor, this is going to be about 5 feet. Again, this is possible if when it was drawn, the student was standing up. Highly unlikely unless people have easels at home and are used to standing up. The original vanishing point for the bottom of the room, it was about here. This is a more natural vanishing point if you were sitting down to draw. So then all the lines would have to be brought down to this point. Okay, so it's not uncommon to get several vanishing points, but if you do, you know that something's wrong. The other videos will talk about how things actually look. So when you move your head, the vanishing points do move. But bear in mind, this is a linear perspective, stylized drawing. It's got certain rules that we have to follow. Even though if you were sitting in this room and moving your head, the room would not actually look like this. But like perspectival architectural drawings, we just follow the rules and make sure that the rules we're using are clearly visible in the drawing. Okay?